restart.
Reboot.
Yeah, okay.
Let's do over.
Go ahead.
First of all, how do you say your name?
Saccone.
Saccone. That's what I thought, but I didn't want to butcher it.
Everyone does.
No, I was going to say that.
No, you would have been right.
But I was like, then I'd say that, and you'd be like, no, it's Saccone or something, and I'd be like, damn it. All right. So, hello. My name is Ben Lesh, and I am here with Sam Saccone for Modern Web Podcast, and we're kind of doing this impromptu. Sam, we're at NGConf right now, and you're here to do a talk. Can you tell us what your talk's about?
Sure. So I'm doing a talk on the history of promises from 1961 to present day, basically.
1961.
Yeah.
They had computers in 1961.
They had really awesome computers. Like, we were sending chimps into space and people into space.
Sure.
So computers were a thing. They looked a little different, but they were around.
Did chimps use promises?
Yeah, I think the chimp got resolved, it was in a couple states. Outer space, state, yeah.
Sure. So how does the history of, was anything even called a promise before the modern day, A plus promise?
Yeah, the first promise word was sort of introduced in 95 in a language called E, and everything latched on to that promise spec moving forward. There are other things like futured and eventuals and all kinds of crazy terms, but the idea of a value that eventually gets resolved to the actual value, that idea has been around since the 60s.
Cool. So I actually get a rap sometimes for people think I'm a person that does not like promises because I work on RX, and there's a crowd that just wants to observable all the things.
Of course.
But prior to that, I think there was a crowd that wanted to promise all the things. So can you tell us what are the main ways that you feel promises are useful?
So promises, in my mind, are most useful when you're dealing with coordinating multiple asynchronous things that eventually will have a value but don't yet have a value. So the traditional example is a network request. You have a network request, it's going to end up in two finite states, a resolved state or a rejected state due to some sort of error. And it gets hard when you want to coordinate, 6 network requests. You get a user ID, and then from that user ID you request some information, you request more and more information based on the subsequent request.
Right.
So organizing that before promises was, you had a huge callback chain, as many of us remember, and it was just nasty, and you had some state some object that you would say I've resolved, I've finished, and you would call into this accumulator object each time, which didn't really work so well. So
right.
Then jQuery came along, introduced their deferred objects, which was more of a callback aggregator, which was great for kind of knowing when everything is done or rejected, but not so great for creating a pipeline of actions.
Right. So the name, in my opinion, the thing that I like promises the best for is for any async thing that I want some sort of guarantee that it's going to be done or it's going to error. Right.
It's going to run to completion. Right. That's the computer science term for it.
Right. Well, that's in the name, right?
Yeah.
So they call it a promise. So in contrast, what do you think about observables? And that's because it's a different async type.
It is.
It's lazy. It's not just wrapping something that's already been called, for example. But what are your opinions on those things? Do you have any that you formulated while you're building up this talk?
Yeah. A lot of my experience has been in Node's primitive stream library, which I know streams are slightly different from observables, but there's a lot of value in getting, basically a stream of data and being able to operate on chunks of that data and then passing on that stream. Obviously, streams sort of fall apart when you try and handle errors, or you want to duplex or multiplex the stream. It gets nasty, and there's tons of great libraries out there to help with that. And RX, in my opinion, builds on top of this idea of multiple events are emitted over time, and we want to operate on them, but we're not sure if it's ever going to stop or whatever. We just know that we're going to get events.
Right.
So they're totally different use cases, like you said.
Yeah.
And they both have a place. But
yeah.
What do you think?
Well, obviously, I think that I like observables a lot, but I think observables are probably more broadly useful in a UI. because they push values. And like a Node server, they're still useful, but not quite as useful because they don't really handle like a back pressure quite as well. Where like if you have like an iterator of promise or an async iterator, you've got that semantic of I'm going to get this next thing, then you get it. Now I'm ready for another one, and so on. So you can handle back pressure. But yeah, I mean, there are some things that promises just make sense for. We actually use promises for like the return value for each, for example, in RX, where you can subscribe to an observable and there's no way to cancel it. So you're guaranteed that it's going to resolve, and promise is perfect for that.
Sure.
Well, how do you feel about cancelable promises? That's really that's a controversial topic.
So Mark Miller, who wrote the implementation for E and wrote the paper on the language, actually has a method called smash on his promise implementation. And the idea of smash was you would have this promise, it would be in some state that was not yet determined, and you could smash it and get rid of it. And in my mind, cancelable promises are really useful. So the idiomatic example in modern web development, in my opinion, is fetch. Fetch, in like an app I'm building right now, I fire off so many fetch events, but a lot of times the user's on a page, and then they change pages in a single page app. And all my fetch requests are still in flight. And so I'd say, oh, it'd be really great if I could just terminate, like with XHR, you just cancel it and you're done, and it gets hung up on the client.
Right.
But with fetch, there's no cancel. And there's a huge thread online about like why it's not. And so you have to cancel it as soon as you get a response from the server.
Is it useful because it's a venable with cancellation? Is that why?
Well, it would be useful if it was a venable with cancellation, but there is no cancel in promises. So I feel like if promises had a cancel like primitive support or a state that they could enter to be canceled, that'd be so useful.
All right. So the next question is obviously why not an observable of one? If cancellation is the thing that you're looking for.
Well, if I wanted to wrap fetch as an observable, then that'd be good.
Right.
It's a matter of embracing the platform versus building on top of the platform. So with the modern web manifesto is we give people primitives, and from the primitives we can reconstruct everything. And fetch, in my opinion, doesn't give us enough primitives. Like as soon as we get the response from the server, we have, you can control everything. You can control how you parse it, how you handle the response, the streamed response from the server, but I don't have control starting out. And I think it's a little bit of a blind spot in the spec, and the community is making their voice heard. So, but you're right, like it could be converted into an observable, and then I would have cancellation, but what happens under the hood? I'm not using fetch anymore. What I use XHR?
Yeah, I don't know. I actually don't like cancelable promises that much. And the reason is because I like promises how they are. Like I like promises as a guarantee, like the name promise. Like if someone gives me a promise, I know that one of two things is going to happen. And I feel like if anyone that has a handle to a promise can cancel it, and I give a promise to like 5 or 6 different consumers, any one of them could cancel it and actually like kind of mutate what's going on with their siblings that aren't supposed to know about them, right?
Yeah, the question becomes, what are the semantics around when someone cancels it? What happens to everything that's attached? Does it just no up? Everything doesn't act? I agree that like potentially it opens the door for weird mutated objects, weird mutation that you can't track where it's happening. And we saw this in Chrome for a while. There was a promise.defer. You could create a deferred promise that was basically an object that had a resolve and reject function.
Yeah.
But that has been dropped.
Because then all of a sudden you can leak that out to anywhere you want. Just be like, here's my resolver.
Yeah, and you can mutate the state of the promise from anywhere.
Right.
You can manually resolve it versus the promise constructor where you do new promise and have the resolve reject. I don't know. The argument of canceling a promise, opening the door for more complexity, I think is valid, but I think that there's a place to cancel work if you just don't want it to happen anymore. And a way to do that is via guard clause or a precondition inside of your handler logic. Like you would set a bit to canceled, and then if canceled, return.
And then you're in the same boat though, because somebody else can set that bit. See, the thing is like promises are awesome because of that guarantee, in my opinion. like where if you want to guarantee like that, you use a promise. Don't use an RX observable. Like don't do that. If you want to guarantee, use a promise. And I think if you want that, if you don't care about the guarantee and you don't care if like multiple folks might be able to like mutate what's going on, then you could use like an RX observable, because it's gonna, like, someone could just have the subscription and unsubscribe from it or whatever. So
yeah, I acknowledge your point on cancellation. However, at the same time, I think that there is a use case for a subset of things, like network requests are a definite use case. I want to cancel my open socket to the server. I want to be able to control that. And since the fetch primitive returns a promise,
right,
it probably should expose a way so I can cancel it. It seems like a big hole in the spec, like the official promise, the original ancestry of promises has cancellation.
right.
Not saying that it's the best thing, but I don't know. I think it has a place.
Sure. There's another primitive, actually Stefan Penner's working on cancellation tokens. So the idea that you could have a cancellation token and you could pass it around to any number of async things, and they could somehow register themselves with that, and then you could say cancellation token, cancel all these things.
Sure.
That of course could result in, you know, a bit more of what we were talking about before, but that's an additional idea. What do you think about the idea of a cancellation token?
Yeah, so it's like an interface that you can choose to opt into using like...
Right. Just if you pass an optional cancellation token in to your promise or whatever, then...
Yeah, it seems okay. I mean, the parallel with this is progress events on promises. A lot of primitive promise implementations, or like userland promise implementations, have progress, which can be useful.
Mm-hmm.
Official promises don't have it. And it's this idea of state, like we're passing around this little state bubble that obviously anytime we introduce state, it gets crazy.
Right, yeah.
Like, there's more complexity and people are going to disagree. It's like, why is it, keep it simple.
Was progress, was that originally going to be in the spec? Where did we leave off then? We left off, we were talking about cancelable promises, right?
Yeah.
And I'm camp cancelable promises are probably not good. And your camp, we probably need them because of fetch.
Yes.
That's an accurate portrayal.
Operations that are detrimental if you don't cancel them. Like you have a limited number of open connections in a browser, right? So if I can't cancel my fetch, that means that my future requests are going to be held up.
Right, but like I get that about fetch, but
Okay.
I don't know if it's worth diluting like like if somebody gives me a promise, like I like to know that nobody else is going to cancel that promise. Like that's like the value of the promise, right? Is I've gotten this thing and I'm guaranteed that it's either going to resolve or reject at some point. But if there's some bit of mutable something out in the wilderness that someone could be like, no, sorry. Like I feel like it takes that guarantee away. And maybe it's an irrational thing, but like I always thought of that as like one of the stronger points of the promise type, was that guarantee. In fact, it was so strong that they named it a promise. And if you can cancel it, then it's just a dirty lie. It's not a promise.
No, you just cancel subsequent work. You don't cancel the promise. I think thinking of it as like you're flipping the state is the incorrect way to think about it.
So like with async, there's three ways that async things end. One, the producer notifies the consumer that it's successfully completed. Two, the producer notifies the consumer that it's completed, but there was a problem. There's an error. Mm-hmm. And three, if you have cancellation, the consumer says, I no longer care about this.
Correct.
Right? And like promises only ever embodied two of those things, which is why they're promises. They cannot be canceled. They're guaranteed that they're going to resolve. And it was determined early on that, well, I don't know how early on, but a fairly like a while ago, that the whole deferred pattern wasn't good because you were leaking two of those notification points out to God knows where, right?
That's correct.
But now we're talking about leaking that third point out of the promise. And like, I get that happens in observable and other cancelable types, And maybe they need something that's not a promise. Maybe they need something not an observable, like a single value cancelable thing that is eager, like, right? But I would hate if I thought like, oh, I'm using this API, it's giving me a promise, but I don't really know what it's going to do because I don't know if like inside of this library somewhere it's a cancelable promise or somebody else has a handle to it. And that's kind of hand wavy, right? Like,
no, I mean,
that's probably not really going to happen, but like I feel like just for the strength of the type, it's maybe not a good choice.
That's sort of the appeal of promises, the primitive idea of promises, not in JavaScript, but in other languages, is that, if someone puts a while loop somewhere deep in a chain of promises, and they do while one, whatever, nothing proceeds, everything locks up.
Right.
Okay, so that still can happen today with promises in JavaScript.
Sure.
Now, given the potential of workers and web workers and basically giving work off to them, that stops being a big concern because we have distributed promises. Now, this cancellation state that we could enter, we have this idea of, let's say we push work into a worker. Say, okay, give me n number digits of pi. Cool. Go do it. Now, if you're a consumer on the page, it's like here doing some stuff, and like they leave the page, the pi computation page. Now that worker's still going. So what do you do as a developer? Like I don't care. I don't want that worker to do anything. Do I unregister like my subscription to that worker? Do I tell it to like die? But if I have an interface that's a promise to the worker, like it's not gonna throw.
Right.
I don't know how you
probably a promise was like the wrong choice for a primitive type in that scenario. Like,
but there are situations where you want to cancel something. You want to stop. You want to say, "I stop doing what you're doing."
Right.
And I think fetch is one of them. So,
right.
Would you say that fetch is promise was the wrong interface to fetch?
I think it might have been, considering like how fetch is used on single page applications. So if your application wasn't a single page, like, and you were just going to dump everything anyways, as soon as someone navigated to the next view, then who cares? Like, it's just going to die. So here's another thing about cancelable promises. So, like right now, as you said, you could have a promise with just a while loop in it, or someone could write a promise and never call resolve or reject. Yep. And you have this never promise. Right?
Well, that's very different than the while loop case, because the never promise won't block. It won't block your event loop.
Right.
The while loop will block the event loop. Everything stops.
Right. Where the never promise is just it's never going to resolve or whatever.
But everything stays in memory.
Right.
Because everything's retained. Because it's not going to garbage collect these chained objects because they're still referenced.
Right. So like it makes me wonder about implications for like if a promise is cancelable, do we need more combinators on promises other than just try and catch? Like finally seems like it would be very valuable in a situation like that.
Well, we've all done the dot catch, do some work to like propagate the error outside of it, and then put a then at the very end.
Right.
And it's like super dirty, and then sometimes you rethrow the error, and it's very strange.
Right.
To emulate that finally better. But
right. But yeah, like a finally seems like it would be important, or even a finally in continue with sort of thing. Like if you cancel this, then I want to do this other thing. But there's not like, I don't really see a straightforward way to do that with a cancelable promise. Like I think that it dilutes the type, and I think that it has maybe broader implications than people realize that really want cancelable promises. I think on the surface it seems like a good idea because people think, oh, promises are everywhere. But I just think that I'm not saying observables or CSP or anything. Just I think that there's other async types that are out there that seem exotic right now because promises are everywhere. But promises were exotic once, and maybe there's a better type with cancellation to handle those scenarios. So you could programmatically tell the difference between one and the other. You've given me a promise and I know it's going to resolve. You've given me a, SAM object or whatever we call it, a task, and I don't know if it's going to resolve or not. It could be a little mutable inside of what's going on.
if promises were cancelable, so let's just run this hypothetical.
All right.
And like I can see, okay, potential case. You kick off a promise doing some work, and it changes some state outside of itself. But then you have in your chain, you have something that fixes the state or resets it, so the global state is no longer mutated, or block scope is not messed up here.
Sure.
And if you were to cancel it somewhere in between there, that state would never get reset, and you're all messed up.
Mm-hmm.
Okay, so I can no longer guarantee that the subsequent calls are going to be executed. Yeah, that makes sense. However, I would say that if you're relying on your promises to always trickle down, then you've written your promise chain and you've written something incorrectly, because any promise at any state can throw.
Okay.
And therefore they skip the subsequent thens and they go to the closest catch, and if there's no catch, then an exception is raised. Well, now an exception is raised.
Right. Yeah, before
so,
it was just
yeah, silent and bad. So I guess I'm not buying this like cancelable thing is bad and evil, because if we cancel it, it's like we threw, but
I don't think it's evil. I think that I'm not all in. Like I don't see it as like a really good thing either.
Are you saying because we can't react to a cancelable state? Because
yeah, I think that's part of it. I think part of it is the fact that that I felt like the strength. I still feel like the strength of promises is the guarantee, and like you have like
there is no guarantee.
Right. Well, assuming that whoever wrote it was okay, like
I mean,
fair. There's no guarantee with like I could give you a function and it could throw or it could do something or right. Like,
totally.
There's no guarantee with any of it, but the idea is that there's a guarantee conceptually. If in a perfect world,
the only guarantee is the then catch pipeline. You're establishing a pipeline that you can represent in code, and you don't have to hold on to variables and manually look at the state of everything. That's the guarantee. Is that if one of these states occurs, I know that my catch is going to get hit, or my then is going to get hit, or potentially nothing is going to happen.
Right.
But I mean, I remember in Backbone days and earlier where I would have like this concept of a view or whatever, and I would render it and I'd set up event listeners, and then I would destroy the view or something would render, data would change, and that event listener would still be bound to something that didn't exist anymore, or like some long running function would be happening, and then, or no, like a data and a model would change, and it'd like try and touch the DOM, that DOM didn't exist anymore, and things would blow up. So what I ended up doing is putting in guard clauses, like we talked about like earlier. It's like, okay, now we put guard clauses in to handle this weird like canceled state where it really shouldn't be there anymore. I just think that there is a place to just terminate work, to just say give up, everything can be garbage collected and everything can be cleaned up. Now, are there other patterns that we could use to do that? I mean, like an event emitter. Event registration is good because when you want to cancel that, you unregister the listener, okay? Which is parallel to observables, like we subscribe and I unsubscribe, but like that guy can still be firing. I just don't care about it anymore.
Right.
So it'd be nice to have a parallel in promises, but I think it would be a useful thing in a lot of primitive APIs that right now aren't cancelable. Don't expose that. Fetch being the one that I think is on my mind because I deal with it every day.
I wrap all my stuff in observables, man. So, all right, let's switch gears a little bit. Promises in Node.
Promises in Node, yeah.
So there was I don't know, I wouldn't necessarily call it a stink. There was a back and forth about promises in Node, and like I guess that my vague understanding of this is there were some Node APIs people were talking about having return promises.
The pull request on Node that's still open.
Yes. And the folks at Netflix in particular that are Node experts, they do not want promises to be returned from these APIs because promises by default try catch all errors. They will trap all errors so they can send it down the promise chain. There's no like an unsafe then
Yeah.
that you could do. And consequently, that ruins how they debug, because the Node folks would rather, at least a lot of them, would rather just panic and let it, like, oh, you've got an error, I'm not going to catch it, I'm just going to let the Node process stop immediately, and then it's going to give me this nice core dump that I can analyze later of exactly the state of everything when that error happened.
Yep.
Right. So that's the big back and forth.
Oh,
What
that's interesting.
yeah. What are your thoughts on that?
So I know DevTools, Chrome DevTools, and V8 have been working on this exact problem of like async stack traces, and they've but like put the hooks into V8 where this is no longer a problem as far as I understand.
So it's not the stack traces though.
It's
The actual memory state, like the state of what things were, like the actual dump.
yeah, I'm not an expert in this, but I think that is now possible to like reconstitute that because DevTools does it.
Interesting.
Yeah.
Interesting. So that's a new development. I hadn't heard that before.
It is very new. Yeah.
So, is this like top secret Sam Saccone knowledge, or?
No, it's not top secret. I mean, it's in V8.
You've got that sometimes. You have a little bit of, especially node related top
You
secret.
just sort of walk downstairs and say, "Hey, Paul, what's going on?" He's like, "Oh, just did this." I say, "Oh, that's cool," and then I know.
Right. So the top secret knowledge that I think is the beans have all been spilled about that now that you had told me about one time before. This is the NPM security vulnerability.
Oh right, yeah.
Yeah.
That was a fun one.
So you discovered that?
Yeah, I did.
You discovered. Can you tell the folks at home what the NPM security vulnerability was in a nutshell?
Sure. It still is. Well, some people, the official Nerd Rage, that sounds too aggressive.
I like it, Nerd Rage. Go
Yeah,
with that.
okay. The official Nerd Rage response is, of course it works this way. That's the whole power of them. Fair. My point was, most people did not know about this. So this was it. In a post-install script in NPM, you can execute anything you want. Like, you can install more stuff, you can compile your stuff, etc., etc. Now, most people, when they use NPM and they publish stuff, they do npm login, and they stay logged in forever because there's no expiration on it. And there's no, like, two-factor auth or whatever. You're logged in, and you're forever logged in unless you log out. And then you have to actually go into NPM's website and revoke your credentials, like your token. Otherwise, the token is still valid, which is okay. So what someone can do is, in a post-install hook, they can run npm publish, so they can republish your own stuff. And it's not republish, they have to bump the semver and then do that. But what we saw with LeftPad was, well, this happened around the same time, is that LeftPad debacle happened, and then someone else took it and published it again. But everyone realized, like, wait a minute, they could have published anything, and because everyone's dependency was squiggly line or caret, they could have pushed any code in my code base. Okay, that was one example. Now imagine a malicious actor publishes something, gets a hold of someone's account with this like worm, and then publishes over your version, just bumps the bug fix semver, so everybody gets it unless they have it shrink wrapped and locked down. And then what that worm does is it spreads and spreads and spreads. And that's like the idea in a nutshell, but I think it's like compounded and made a lot worse because of the way people write modules nowadays, where everything is interconnected. Like, the big reason why LeftPad broke the internet is because it broke Babel.
Right. So
Period.
the LeftPad thing is where the guy unpublished his npm repository for LeftPad, and like all these other little libraries depended on LeftPad, and then other libraries depended on those libraries, and so on. So
everyone's build broke, but like the truth is it was mostly because of Babel. Babel had a dependency on LeftPad, and so when Babel broke, most people's automated CI process broke because they could no longer compile. And then because leftpad was like unpublished, it required Babel to be updated and every single Babel package to be updated, and it was a big mess.
Right.
It broke the internet.
So the security vulnerability would then be that, let's just say that for some reason I am able to publish somebody else's small repository that is used all over the place. I could publish a post install script that ran any arbitrary code, including republishing whatever anybody else has, like locally in that repository.
With the word.
Yeah, they're actually their own, and it would just like be viral. So you would publish a package that when someone installed it caused them to automatically publish their package. Probably having rewritten something to do exactly the same thing for anyone that installs that package and so on.
Exactly.
And it's like a really, really, really horrible security hole. So log out of NPM, folks.
NPM logout is good. But I know NPM is working on the security people are working on several things based on community feedback, which is great, to enable two-factor auth and basically lock down your account more to plug this hole, sort of. But the safe thing to do is not stay logged into NPM, because it's a very scary thing.
That's good stuff.
What else? We covered everything.
We did.
Everything in the world.
What about me? Do you have any questions for me? He's like, no. No. You don't like cancelable promises. I'm not talking
I don't know. When did you take over RX?
Oh, so this is the story of that is shortly after I started at Netflix, I was taken aside by Eric Meyer and Jafar Hussain and Ben Christensen, these guys from the ReactiveX community, and they're like, hey, do you want to try to rewrite like our own version of RX, because we have these set of concerns about debugability and performance and that sort of thing. And I'm like, what? I'm not, I didn't feel like I was the most qualified for it, certainly. But I was like, sure, I'll do that. And the truth is that I think that at the time, Matt Pavlicek didn't really, like at the time weren't really planning on like, oh, we're going to publish like a new version of RX. And then once we saw like some momentum with this, then these folks in the ReactiveX community, they talked to Matt and they were like, we'd like to do this as the next version of our RxJS. And I feel like at the time, and I'm sure that he'll say the same thing, that might have blindsided him a little bit. I didn't really understand. I'm just like, oh, look at me, I'm happy and I'm working on a library. It's all popular, isn't that cool? So it's interesting, but fortunately it's worked out really well. We're able to. I mean, it's a new major version, so it's completely different than the old version.
Sure.
And the community's growing quite a bit, and Matt is of course still the creator. Like he comes and does his huge talks, and he's a big personality, and everybody loves Matt. This wizard hat.
It's a great wizard hat.
So I wouldn't say like, I know that I've been doing all of the RX5 stuff. I'm not the owner of the wizard hat though. Like I've corrected people a few times in other like podcasts and stuff. Like, so you're the creator of RxJS? It's like, no, I might have created RxJS 5, but that was done in a community effort, and Matt created RxJS 4 and 3 and 2 and 1.
Are you seeing a rise in other RX-like libraries?
Yeah. I mean, Andre Staltz, he wrote his own like kind of micro observable library, and he actually contributes to RxJS 5 too. There's a lot of them out there. I'm hoping that they all, at the very least, implement the symbol observable, which is part of the observable spec. And the idea with that is just to provide some sort of interop. So if I see an object and it has symbol observable on it, I can call a method and get back an observable that fits a certain contract. So I know how to read values from that observable type and subscribe to it.
Is there a common test suite that people run against?
That's a good question. I don't know that there is, unless Zen Parsing might have one. I know that he has some tests, but I don't really know. Like, I think that a lot of his tests are around, like, here's tests for my spec. Like, I don't think it's a test for any sort of, like, interop compliance.
Do you think that there is, like, with Angular 2, using, like, basically everything around observables and more people latching on, do you think that there might be value in, the similar path of the A+ spec for promises, but one for observables to get community buy-in and to show, standards committees like, hey, this might be a good thing to roll in.
Yeah, I think so. I think that, weirdly enough, even though when you look at observables and you think, oh, there are multiple values and there's 3 different handlers and there's all these composable ways that people use them in RX and other libraries, like, I think that spec compliance suite for something being observable would actually probably be much smaller than, say, like an A+, because A+, I think the Promise spec has a little bit more nuance to it about, like, what the different methods have to be on it and how they need to behave in certain scenarios, where, I mean, observables really, when you shake it right down, are functions that take an observer and do things and return a subscription. So, there's no, like, async guarantees and things like that. But yeah, I think there would be value in that for sure.
Yeah, it seems like the potential to kind of push. I mean, there's streams in the browser today which feel similar to RX. I mean, I know they're not exactly the same, but they feel similar. And so it'd be interesting to see if that could be sellable. TC39 be like, what if streams implemented observables, or observables were usable with streams?
Right.
To provide people with a slightly nicer interface.
Yeah, so, I mean, theoretically, if everything has its own little symbol that you can, like a symbol iterator is today, then you could have stream be like, oh, if I'm making a stream with, I'm passing some object to, like, a stream from, and it would be like, oh, well, does this object have symbol observable on it? Well, I know what to do. And that's what we're trying to do with observable from. So observable from in RX handles promises, it handles iterables, it handles other observables, and async iterators, or async iterables are another thing that I'm going to add in the near future. I started spiking out a branch to do that, and I got pulled into something else, but the idea being that you say observable from and you give it some type and it would just kind of know what to do.
It feels a lot like what Bluebird and Q did with Promisify. Like, give me a thing.
There's an issue actually for, like, the Promisify thing where you could be like, oh, give me this, like, take some, like, the file system in Node or whatever and like change it to all be
Promisify all. Yeah.
So there was I think Benjamin Grunbaum was asking for that in an issue. So, well, hey, it's been really awesome talking with you. This has been one of the best technical podcasts I've ever been involved in because, contrary to popular belief, I do like promises. Cancelable promises, I don't hate them.
I mean, observables.
Yeah, I don't hate those either. They're okay.
They're okay. I used them like twice.
All right. Sam Saccone, thank you for coming on our podcast.
Thanks, Ben.